Okay, good evening, everyone. I'm Suresh alongside Eric, Chester, and Philip from Team 1. We are online class for 549. Today, we deep dive into the intricate landscape of cybersecurity in the aviation sector. Let's start our journey by understanding the challenges that lie ahead. So before we begin, let's take a quick look at our agenda. We will navigate through the abstract, explore the aerospace industry, and address the problem of communication gaps, and also examine crucial statistics and discuss the regulatory framework. Fasten your seatbelts. It's going to be an insightful flight. This is our abstract. So our mission is clear, bridging the communication gap between the technical experts and decision makers who are non-technical in nature. So picture it as a strategic move in cybersecurity, in the chessboard of cybersecurity. Moving on, let's start by understanding the aerospace industry, where the complexities of design, production, and maintenance coverage are complex in nature. Today, we explore how the industry's reliance on interconnected systems make it susceptible to cyber threats. So these three are the aspects that we are going to cover in the slides. The problem statement, as I explained in the outline, our challenge mainly lies in the communication within the vast area of aviation regulations. Inadequate communication poses risks to safety and cybersecurity. Our goal is to decipher the regulatory language and ensure seamless communication. The slide explains about few statistics. As you can see from the 2019 to 2023, the numbers are alarming, increasing numbers of attacks against aviation industry. And for 2023, we have only close to 6 months data, not all. It's still alarming. So from here on, I will hand over to my teammate, Eric.
Thank you, Suresh. So first up, I'm going to give some real-world examples of why we should care about cyber attacks against the aviation sector and how communication gaps and delayed decisions exacerbated matters. So in March 2021, Air India had the personal details of about 4.5 million customers around the world get compromised, which included their passport information, credit card details, birth dates, name, and ticket information. Hackers had access to Air India systems for 22 days. Delays in communications led the airline to not being able to notify all customers for up to 3 months after the incident occurred. In 2018, with Cathay Pacific, 9.4 million customers were affected, and then Cathay Pacific took 7 months to report the data breach, damaging the company's reputation and potentially further harming the customers by not letting them respond to the incident in a timely manner. In 2021, for Singapore Airlines, 580,000 customers had their data leaked due to targeted data breach. Part of the failure that caused this data breach was attributed to a lack of communication and a failure amongst stakeholders to discuss what cybersecurity measures needed to be implemented. The incident emphasized the need for swift communication and response times to help maintain trust with customers. The attack itself also specifically targeted the airline's transport communications and IT vendor SITA. So these are 3 examples that stress the importance of effective communication and timely responses in aviation cybersecurity. Next slide, please. Now we're going to switch gears and discuss aviation industry regulatory bodies and regulations, and then get into more detail about relevant cybersecurity regulations in the US on the next slide. As you all can imagine, the aviation, go back one slide, please. As you all can imagine, the aviation industry is heavily regulated to ensure the safety and security of all involved, but especially the passengers. Many of these regulations were developed to be standardized across the industry, regardless of which specific company or airplane operator is involved. Now, there are a number of regulatory bodies to include the Federal Aviation Administration, International Civil Aviation Organization, or ICAO, and Transportation Security Administration, or TSA. Please bear in mind that these are the regulatory bodies that affect the United States, and each country and or region have their own authorities, such as the European Union Aviation Safety Agency, or EASA. The regulations that these organizations issue cover safety, security, environmental concerns, and even cybersecurity. Of course, as technology progresses and the aviation sector grows, regulations must grow and progress with it. Ideally, there should be global standards to allow for interoperability between nations and ensure that passengers are flying safely and securely, no matter where they are in the world. When regulating such a technical field, there are communications barriers, not necessarily from utilizing different languages, although that does not help, but from taking complex ideas and rules and making them comprehensible by all the stakeholders, as well as dealing with technical jargon, such as porpoising or thermal thicket. This is what makes it so important to have effective communication in the aviation sector regulations, because there are so many nuances to this field and misunderstandings can lead to a loss of life. Effective communication also helps bridge the technical and non-technical aspects, ensure regulatory compliance to include adherence to cybersecurity regulations. Next slide, please. Attempts to implement wide-scale mandatory cybersecurity regulations in the United States are still relatively new in the aviation sector, with the TSA only having issued an emergency amendment to TSA-regulated airport and aircraft operators on cybersecurity practices in March of this year. The new TSA rules require airport and aircraft operators to develop an improved implementation plan that describes measures they are taking to improve their cybersecurity resilience and prevent disruption and degradation to their operational technology and IT infrastructure. The rules also require organizations to proactively assess the effectiveness of these measures. The plans must develop network segmentation policies and controls to ensure that operational technology systems can continue to safely operate in the event that an IT system has been compromised and vice versa. The plans must also create access control measures to secure and prevent unauthorized access to critical cyber systems. Additionally, the plans must implement continuous monitoring and detection policies and procedures to defend against, detect, and respond to cybersecurity threats and anomalies that affect critical cyber system operations. And lastly, the plans must also reduce the risk of exploitation of unpatched systems through the application of security patches and updates for operating systems, applications, drivers, and firmware on critical cyber systems in a timely manner using a risk-based methodology. These new TSA rules provide specific cybersecurity requirements designed to prevent and defend against cyber threats. Previously, TSA required airport and aircraft operators to take basic steps, such as reporting significant cybersecurity incidents to the Cybersecurity and Infrastructure Security Agency, or CISA, establish a cybersecurity point of contact, develop and adopt a cybersecurity incident response plan, and complete a cybersecurity vulnerability assessment. This new guidance is more proactive in trying to get the stakeholders to prevent cybersecurity issues, not just report on them. So that was a quick overview of aviation sector specific regulations. I'm now going to turn it over to Chester, who will be talking to you about cyber risk management in the aviation sector. Thank you.
Thank you, Eric. Cyber risk management in aerospace has many interdependent information and communication technologies called avionic systems, from weather information to global positioning, flight controls, communications for safe operation of the aircraft, and data sharing with pilot, crew, air traffic controllers, which all have cyber vulnerabilities, as well as the aircraft design and manufacturing. Maintenance can have significant risks of potential cyber attacks. Risk management by identifying what needs security controls and implementing and applying necessary safeguards from vulnerabilities and threats are critical for safe flight, manufacturing, and operations. Next slide, please. With many integrated information systems, the aerospace industry must adapt to evolving cyber landscape with many security measures to mitigate vulnerabilities and threats. With the aerospace, many partners and peers, collaboration is critically important to share cyber risk management strategies, including real-time threat monitoring, threat intelligence, and applying modifications or patching to software, along with supply chain advisement on cyber risks. Next slide. The strength of the aerospace industry is the work of many industry regulators and associations that advise and ensure safety and security measures are implemented. Other dimensions for strengths is research and development of the financial investments of aerospace companies and industry as a whole, creation of state-of-the-art technologies and skills were first acquired. Next slide. Conversely, cyber risk concerns in the aerospace industry are legacy systems and hardware, patching commercial software, and insecure supply chain. Addressing or staying vigilant on weaknesses can lead to catastrophic consequences, data breaches, and safety, operational, and flight risks, or even death. Next slide. The most significant threats are state-sponsored advanced persistent threats for primary espionage purposes, for aerospace technology, and information and data exfiltration. Another major threat is insider threat to spy and gain competitors' edge or one to lead instances. Next slide. The most common vulnerabilities are lack of or negligence of commercial software notifications, patching, insecure supply chain security measures to protect aerospace manufacturing and affiliated hardware and software developers, and staff training about cybersecurity measures and strategies. Implementing comprehensive cybersecurity and awareness training programs, supply chain improvements, and consistent software patching will aid in mitigation effort and improve cyber defenses. To address vulnerabilities is an overarching industry-wide goal to be cyber resilient. Next slide, please. Inherent risks of the aviation industry are threat actors such as state-sponsored insider threats or intellectual property espionage, cyber risks like DDoS attacks or password cracking, phishing, or ransomware attacks are significant concerns for cybersecurity in aviation industries. Next slide. These attacks affect the CIA triad, such as loss of communications with the aircraft and to ground control, loss of avionics or airplane controls like engine, flight controls, navigation systems, and a threat of loss of life. Another impact is the ability of attackers to automate processes with AI to threaten or breach onboard and in-flight aircraft systems, or use sophisticated remote attack tools to cause devastating or catastrophic damages or casualties. Now to our final presenter, here is Eric.
Good evening. So the most effective countermeasures is what I'm going to discuss, and they've been covered a little bit by some of the previous presenters. I'm going to go a little more in depth into what we're trying to accomplish with these countermeasures and how to communicate them to a broader audience. These effective countermeasures are included in regulations and periodic guidance documents. So the aviation sector is working on addressing the threats and vulnerabilities previously discussed. However, as we've seen, there's a lot of different organizations involved, and while they each have their own area of expertise, cybersecurity is not necessarily their area of expertise. So communicating these effective countermeasures and the threats and the vulnerabilities is important. Now, one of the ways aviation is different from some other forms of critical infrastructure, for example, government, is that it includes operational technology in addition to information technology. We're all familiar with information technology. That's the computers you use at your desk. Operational technology is the systems and software that run machines like pumps for fuel and engines and air handling and fire suppression. And that makes things more complicated because it's a separate area of network controls with its own protocols and its own architecture. One of the things you want to do when you're communicating these effective countermeasures is keep in mind that you should be risk-based rather than prescriptive. Cybersecurity is changing fast, quote, faster than the speed of government. So you need regulations that are risk-based, that adapt to how cybersecurity changes, rather than just requiring checkboxes in what's going to be a rapidly outdated checklist. The countermeasures also form a multi-layer defense with the various layers working together, so the security as a whole is greater than its parts. As discussed by Chester, one of the things you need to start with is a vulnerability assessment. It's part of the risk management. And as I said before, you have the IT network and you have the operational technology network, and the vulnerability assessment has to address both. You also need to address airplanes on the ground and the equipment and hardware and facilities like airports that they're in. You also need to address airplanes in the air. And you need to not only have the manufacturers, but the vendors, the contractors, and all the various staff and personnel involved in aviation. As you know, just a brief look at the New York airports, you can see you have the TSA, you have customs, you have the various airports themselves, you have the equipment manufacturers. Addressing how all of these parts work together in a vulnerability assessment is going to allow you to prioritize and focus on what needs to be done and what needs to be done first. Network segmentation is also a very important countermeasure. It separates, one form is separating the operational technology networks from the information technology networks. And that way, the idea is even if the information technology networks get compromised, and as we've seen from previously discussed incidents where customer data was stolen, that happens fairly regularly. If that happens, you want to be able to have those sort of forming their own walled garden so the operational technology networks are not affected, and you can still fuel the airplanes and you can still run the engines, and that won't be affected. You also need to segment the airport operational technology from the airplane operational technology, so that if the baggage handling equipment is being impacted, the planes can still take off and land. Working with network segmentation is access control. And role-based access control supports the work done by network segmentation, because this way you can only access the parts of the network that you should or absolutely need to. And the access control needs to take into consideration that you have internal access, like the mechanics and the ticket sales folks, and you have external access, like the manufacturers who want to get data from the aircraft engines while they're operating. And again, you have all of those various groups that are either internal or external that are going to want access to the networks, such as customs, contractors, Port Authority, Transportation Safety Administration, a whole host of actors. Access control also needs to include physical access as well as electronic access. So for very important areas, you can set up multi-factor authentication for physical access using a keypad and a PIN, much like password and a login code from your phone for electronic access. And this way you can keep folks segregated only into the areas they need. Continuous monitoring is another layer that works with access control and with network segmentation. It provides network visibility, which helps shorten the time to detect when somebody's on your networks doing something they shouldn't. It shortens dwell time, so you don't have bad actors on your networks for 22 days before you notice what's happening. And for incident response, it can tell you where the intruders were, where they moved, and what parts of the network they accessed, which gives you an idea of what parts of the network are still safe to operate. And it provides detection possibilities if the attackers are coming in and exploiting a 0-day, which is an unknown vulnerability. If you, the monitoring can detect the behavior or the activity that the exploit is doing, and you can tell, hey, here's people moving into the parts of the network they shouldn't be. Patching is another part of the vulnerability management. And to do your patching, you need the inventory. So you know what you have and where it is, because if you don't know, you can't protect what you don't know about. It's complicated, it's expensive, but you need to identify patches, prioritize which ones get applied, acquire them, make sure you've got the right patch from the right vendor and not something somebody else made up. You need to install it, and then you need to test it to make sure it works with the equipment and hardware and devices you already have on your network, which is why it's all complicated and can get expensive. But as we've discussed previously, vulnerabilities in the software and firmware are one of the common ways to gain access to the networks. So patching blocks that. And part of patching is establishing baselines. And that way you can tell when your equipment or your networks are operating outside of a baseline. And that's another flag to check to see if you're having an incident. And finally, black swan events. You can, if you plan for them, you can recognize the way they'll be impacting your network as they start, and that gives you a chance to plan how to mitigate them early or how to stop them early to keep a black swan event, which is something horrifying, happen, and maybe turn it into a mere incident where nobody gets hurt and nobody loses their data. So in conclusion, next slide, please. The cybersecurity is complicated, and complicated is hard. That means the devil is in the details. As a real-life example, you can have AES 512 encryption, which is the sort of encryption used by the National Security Administration. It's very strong, but if you've implemented it incorrectly, because it's complicated, and you're cycling between 255 preset encryption keys, it's not going to work the way you want it to. So communicating nuances like this to audiences who may be subject matter experts in their own area of knowledge, it's hard to communicate the nuances to them in cybersecurity when they don't have that background knowledge. And since we've discussed before with aviation, getting it important is correct because we want to avoid loss of life. And so the last slide has our references, and we are available if there's any questions.
Okay, thank you.